Welcome back, aliens. My name is Avin Reddy, and in this video, we'll talk about Neo blockchain. So, I'm assuming that you know about blockchain, at least basics of it. If you don't know about it, that's completely fine. You will find a link in description. You will find a link where I'm talking about the basics of blockchain, and that should work. Now, let's come back to Neo blockchain. Now, Neo blockchain is not new. In fact, we have so many blockchains in the world, right? And everyone is trying to solve the same problem. Okay, what problem I'm talking about? The problem is the first one, the trust issue. Yes, internet is there from a long time, but internet was built on trust. But nowadays we don't trust internet, right? Because all these companies, they own your data. Yeah, that's right. I mean, you can control your data, you can update, you can delete if you can, and you can post new data, right? But this company own your data, and we don't want that. We want the control. We want to own our data. Our next issue is with the, in fact, we have so many issues to talk about, but one of the issue which everyone knows about is the transaction cost or the banking hours, right? So if you do a transaction, you want to do some financial transaction, you have to do that with the help of a bank, which will charge you huge amount of money, and they have a power when to do it and when not to do it. We have some working hours, right? Now, to solve that issue, we have a concept of cryptocurrency. Of course, there are multiple reasons why we have it, but let's talk about cryptocurrency. Now, cryptocurrencies are a way you can use that instead of using a fiat currencies. And yes, in some countries it's not legal, in some countries they are supporting it. But ultimately, that's the future, right? We will be doing transactions in future with the help of cryptocurrencies. So as I mentioned before, every blockchain is trying to solve the same problem with in a different way. Now, Neo is also there, but then Neo is not a new blockchain, right? It's there from a long time. Neo was launched in 2014, but yeah, the name was different. The name was Ant Shares, but later on they moved to a different name called Neo. And one of the things I love about Neo is the way they upgrade. And that's very important, right? Because blockchains are new technology. And whenever you have a new technology, we are still trying to find a standard where all the blockchains can follow. And then there will be a day where we will be having a proper standard, right? But then if we talk about a blockchain, what helps to the users, what helps to the developers and the company who is using it is the ecosystem. In a blockchain, if you have an ecosystem where you get all the thing inbuilt, it is much easier to build with. And that's where Neo excel. And so Neo is coming up with N3, which is Neo third version, and it is amazing. So what are the features it provides? So you can see, I just went to the neo.org. This is an amazing website. And okay, now there's a launchpad, Polaris launchpad, but this is only for this time if you're watching this in this year, this month. But if you're watching this video later, you'll not be having this launchpad. But this is a hackathon. If you can participate it, you can just click on this learn more, and you can participate and you can win the grand prize. Now coming down, let's talk about the features, which is very exciting. Now, one of the amazing thing about Neo, which I mentioned before, is having a good ecosystem. And the list of features you can see there. But then let's start with the last one, which is the multi-language, and that is amazing. See, the problem is blockchain is awesome, of course, and then we have so many blockchains available, right? But one of the thing about the Neo blockchain is supports multiple languages. Example, let's say you know Java, you know C#, but then if you talk about other blockchain, they say, hey, you have to first learn this language, then you can work on the platform. And that's a bit tricky because blockchain itself is a new technology. And now you are asking them to learn a new language. It becomes a barrier, right? Neo says, hey, don't worry. If you know C#, if you know Java, just get in. In fact, it's about multiple languages, which we'll see in some time. The next feature it provides is something called oracles. Now, there's one more thing which I forgot to mention is this is not a single video. We'll be having a series of video. In the upcoming videos, we'll write a simple smart contract, right? So we'll see the entire flow. So if you want to be a developer, what are the tools you need? How do you build a smart contract? Which languages you can use? We'll see in those particular videos. In this video, we're just talking about the basics. Now coming back to the features it provides, which is a native Oracle. Okay, now if you don't know about Oracle, I'm not talking about the company here, but Oracle simply means data, right? I mean, the data which is from the external world. In the blockchain world, if you talk about the data which is stored in blockchain, all this data is actually coming from the transactions, right? So when a user is doing a transaction, that data is a part of a blockchain. But in some transaction, maybe you want the data from the external world. Maybe you want to know the current cricket score. Maybe you want to know the current temperature. Maybe you want to know the stock price or the cryptocurrency price. You can get this data from the outside world. But again, why to go for the outside world? So Neo says, hey, let me provide that native to the platform. Next, it provides something called a Neo ID, right? So you have a sovereign ID with inside the system itself. Okay. When you talk about blockchain, when you talk about decentralized stuff, of course, you want to store your data in a decentralized system as well. And that's where Neo provides you something called NeoFS, which where you can store your data. Doesn't matter what type of data you have, you can store that in NeoFS. Okay, now what next? See, one of the thing with the other blockchain is they provide different services, right? But to access those services, we have to specify some weird numbers which you can't remember. What if you can just map that number to a name? And that's what we do with the DNS, right? The domain naming service. In the same way, in Neo, we have a Neo name service. So basically, for whatever complex number you have, complex address, wallet address, you can map it to the name. Okay. Of course, blockchain itself is trying to solve different issues, but there are some issues in blockchain itself. Now, if we talk about Bitcoin, we have the number of blocks required to achieve finality, right? Maybe 6 blocks, right? So 6 blocks is around 1 hour. So if you want to confirm a transaction, you have to wait for 1 hour minimum. That's not the case with Neo. So they say it is 1 block finality. Now, what it means, once you have a block, it's confirmed. Now, how exactly they do that? They uses a different consensus mechanism here, which is DBFT, which is Delegated Byzantine Fault Tolerant. We'll talk about it in some time. The next big feature is the tools. Now, this is where I was struggling when I was learning blockchain for the first time because, of course, a new technology, a new language, but then the lack of tools. So just to make things easy, we have tools available and you can check them out. And of course, the most important thing, you can write smart contracts. Now, what a smart contract? This is basically a code which you write on the blockchain, which will help you with the transactions. Now, this transaction can be anything, right? Now, this transaction can be a simple money transfer. This transaction can be a transfer of a digital asset. Now, what is a digital asset here? So you can imagine NFTs, or let's say if I want to digitize this remote, I can do that, right? So I can create a digital version of it and I can sell that version. Maybe like a house property papers. I mean, you can imagine, right? So it doesn't matter what object you have in real world, we can create a digitized copy of it. And you can transfer those assets with the help of the smart contracts. Okay, now let's talk about the number of languages it support. So we have talked about Java and C#, but you can also see we have a support of Python, easiest language to go with, and then we have Go to go with, and then we have TypeScript you can work with. But if you know JavaScript, you can learn TypeScript, and it supports that as well. Now, what makes Neo different from other blockchain is the system of dual tokens. Now, of course, in most of the blockchain, we have only one token, which they make as a native token, and they use that token for both the purposes, for investment or for transaction. But in Neo, we got two different tokens. One is a Neo token, and second is a gas token. And you can guess it right. Neo token is used as a native token, and gas is for the transaction. But then we have a slight twist here. The twist is the Neo token is not just a native token, it's also a governance token, which can be used for voting. Now the gas token, yes, it can be used for the transaction fee, but it was designed to reward for the participating in the governance. And this makes it more powerful, right? So we got two tokens, Neo token and a gas token. But then question arises, do we mine Neos? Not exactly. So when the blockchain was launched, they have generated around 100 million Neo coins, and they are into circulation. But yes, when you talk about gas, you can generate gas coins, right? So the Neo is already generated. In total, we have a supply of 100 million. As I mentioned before, Neo supports something called DBFT, which is Delegated Byzantine Fault Tolerant. Now, how it works. So first of all, let's talk about Byzantine generals problem. So let's say we have 5 to 6 generals and they want to attack a particular area or a country or a city. Now, when they want to attack, they are in different location. And we have to make sure if they want to win, they have to attack that city at the same time. So how will they know at what time they have to attack? So of course, there has to be some communication, right? But what if one of the general is malicious, have a wrong intention? Maybe he is corrupt. Or maybe the messengers between the generals are corrupt people. So in this case, how will they come to a consensus? So that's where we have Byzantine's general problem. To solve that, we can use something called POS or POW. But here we use something called Delegated Byzantine's Fault Tolerant. Now here what we do is we have something called token holders or Neo holders. Now they will elect someone who is called a delegator or a delegate. Now this delegate will verify a particular block. So every time you have a new block, they will verify the block. And this particular block will also be verified by the other delegates, right? And if there's a 60% vote, if there are enough votes, this will go ahead, right? And that's how the entire thing works. So we don't have to do the complex processing which we do in POW, which will affect the environment as well. It's time to start with our first code. In fact, we'll write our smart code in the subsequent tutorials, but first we have to do the setup, right? So you need some IDE or some setup to get started. So let's get started with the code. Now, in this example, we are going to write a smart contract with the help of C#. And of course, you can mention your favorite language in the comment section. I will try to create a video for that as well. In fact, the toolkit is built on C#, so we'll start with that. Now, if you want to start with Neo, of course, you need to have some runtime, right? Now, the runtime it needs is .NET. Now, .NET 5 works. 6, sometimes it works. I don't know what went wrong when I was doing it for the last time. But try both. When you download .NET 6, you will get it and it should work, but then .NET 5 surely works. And for my last session, I have used .NET 5. It was working. So the first thing you need is .NET. But how will you verify that you have .NET? It's very simple. You can open your command prompt and you can say, hey, .NET, and you can ask for the version. And if it replies something, okay, is it 2 hyphens? Yeah. So when you say 2 hyphen .NET hyphen version, you can see it says 6.0. It should work. We'll try it out. Otherwise, we'll install the .NET 5th version. Now, if you don't have this setup in your machine, that's completely fine. You can say .NET download. That's a spelling mistake there. And it will take you to the official website of Microsoft. Let's see if we can get that set up here. In fact, we need .NET SDK download. Okay, so you can see when you go there, it will show you some options. So you can select 5 or 6. Any of this should work. Make sure that you're downloading the SDK, and 6, yeah. You can go with this and this should surely work. So that's one option. Otherwise, you can go to .NET.microsoft.com. You can mention your version number, and this is the page it will take you. Download .NET 6.0, and you can download the Windows version. Of course, you can select which version you're working with. So currently, I am with the 6th version, and the OS is Windows. So I will click on this one, X64. Okay, it will take some time to download. In fact, in my machine, I already have it, and it's very simple. I just have to say next, and it will download or it will install the .NET for you. Now, after the installation, again, you can try out this .NET hyphen version. Make sure that you reopen your command prompt because that's how it applies the settings. So close the command prompt, reopen, and enter this. It will give you the version number. Now, once you have everything with you, once you have this setup, once you have .NET version, what next you need? The next thing you need in your machine is a place where you can type your code. Okay, a place where you can connect with the toolkit as well. Now, Neo is so developer friendly, it provides you some toolkit. So you just have to download VS Code. Let's go here and say download VS Code. Okay, here we go. So you can specify which OS you're working with. So I'm using Windows, so you can click on that and it will download that in some time. Okay, but in my machine, I already have VS Code, so I will just click on VS Code. Do I have that? Okay, it's not showing, so we have to install it. Okay, so once we have the VS Code downloaded, it's time to install that, and you can see it's very simple. I just have to say next, and things are good. Okay, so let's launch VS Code. So basically, we got our ID here, right? Now it's actually easy, right? You can just write a code, you can open a project, you can add a code, and it should work. The only thing is, Neo provides a toolkit to work with. Now, where you will get that toolkit, it's very easy. You just have to search for the extension. So you can see in VS Code, you can click on extension, and the extension we want to add here is Neo Blockchain Toolkit. So just click on install, and it should work. So it will take some time. Okay, done. So we got our toolkit, we got our extension. It's time to explore. Now, of course, we can create a new project, a blank project where you can write a smart contract, and we'll run that on Neo. But if you can see, we have an option of Neo N3 Visual Dev Tracker, and you also have Neo here. Let's click on this one, N3. Now, as I mentioned before, N3 is the Neo 3rd version, and it provides some awesome features. Now, if you come back here, you can see we have 2 options here in the blockchain. So on the left-hand side top, So basically first you have to click on N3. Then it will show you option of mainnet and testnet. Now, initially we'll work on testnet because we don't want to waste our cryptos. But if everything goes good, we'll also try out mainnet. Now, this is where you can test your code and you can do experiments, and it provides different options, different networks available here. This is where you will be having your wallet, where you can put your private keys. This is where you will deploy your smart contracts, and this will be a opening prompt. So you can see it says open a workspace folder, open blockchain explorer. We'll see that later. But as of now, let me just use any of this network, any of this test network. I will say right click, and there's an option of open Neo N3 Visual Dev Tracker. If I click on that, you will see some numbers. You will see some table here, and in some time, as you can see here, it is getting updated in every 45 seconds, I guess, or 40 seconds. Maybe less than that. So if you wait for some time, you will see a new block. So you can see this is a recent block now. It just got updated. And if I click on this text here, it will give all the information about that particular block. So this is a block hash, this is a block size, the time, the Merkle root. Then we have all the other information, right? And this will be useful once we start writing a smart contract. So when you do a transaction, when you create a block, it will be available here. Now there's one more thing. You can actually create your own private net if you want, and otherwise you can also use the test network, where we have done the setup for the VS Code, where we got .NET version, we got VS Code, and we got the extension as well. So that's it. Welcome back, aliens. My name is Navin Reddy, and in this video we'll talk about Neo blockchain. Specifically, we'll talk about the white paper of a Neo blockchain. In the first video, we have talked about the basics of it, and then we are moving towards the smart contract development, right? And of course, we'll see some examples as well. But sometime, or not sometime, it's every time, whenever you write a code, it's important to understand the technology. And the best way to learn a blockchain technology is to read a white paper. I mean, irrespective of which blockchain you go for, it's important to go with the white paper first. Now, of course, this white paper is very important. You have to read this from start to end to understand it properly. We'll go through some important points which will be useful for the tutorials. Okay, we'll focus on the important point. So this is the official documentation of Neo, which you can see on the screen. We have a Neo white paper. I will share the link in the description so that you can read it from top to bottom. Now, what is the idea behind a blockchain? I mean, of course, we can link a blockchain technology to a cryptocurrency. But you have to also remember that we can use blockchain to build applications. We call them as dApps, right? Now, why we are doing it? See, we are basically trying to solve one issue, which is the trust issue, right? And whenever we have an asset, it can be a currency, it can be a physical asset. We want to represent everything in the virtual world or in the blockchain world. So somewhere we have to take a physical asset and convert that into a virtual asset. Now this can be a simple phone, this can be a house, this can be NFTs, paintings, right? And we do that, right? So we basically take a physical asset and we put that into a digital asset. And the most important thing is, of course, we can do that by taking a picture as well. But the most important thing is we need to know who owns that particular asset. Right? So we have to link it with the hash value, and we have to put that data somewhere which will not be deleted. So no one should be able to modify it. And that's where the emerge of blockchain is coming, right? Because that's where it is emerging. Because we can save a physical asset into a virtual form, a digital asset into a blockchain, and you can track it. So that's the first point we have here. So basically, using Neo, we are trying to build a smart economy where the first point is a digital assets. If you see the white paper, it says digital assets are programmable assets that exist in a form of electronic data. Basically, you take a physical asset and you convert that into digital asset, and it should be able to track it. So you should be able to track that particular asset, and you can actually send that asset from person to person or from company to company. The way you buy NFTs, the way you buy, let's say you want to buy a property. So you don't have to physically use papers. You can use a virtual asset. You can use NFT for a house, and you can just, you can trade with that. But then one thing to remember, whenever you talk about transferring of assets from one person to other person, how will you do it? And for that, you have to write a code. And that code in the blockchain world, we call it as a smart contracts. So imagine smart contracts as a simple code which you can use to transfer asset. Maybe if you know programming, it can be a simple variable by saying, hey, we got a sender, we got a receiver, this is an asset. So we are sending this asset to this person, provided there are some conditions which are met. Maybe if you receive an amount in your bank account or maybe in your crypto wallet, maybe there is a shipment which you want to do. Once a customer receives the shipment, then the transfer should happen. So those are the conditions you can mention, right? And it can be done with the help of smart contract. So the moment you talk about smart contract, we have two types of asset here. The first one is a global asset and the second one is a contract asset. So we have a global asset and a contract asset. And you can guess it right? So global asset means global. It can be accessed from anywhere. How about the contract asset? Now this is specifically for the smart contracts, so which can be used inside a smart contract. Now that makes sense, right? So we have a digital asset which comes from the physical world. The second one is the identity, a digital identity. So for every access, how do you prove that you are that person? So example, if you say, hey, I own this NFT, if I own this house, what's the proof? And that's why we need identity. How do you prove yourself? Of course, we have to use a certificate. So in the cryptography world, or you can say in the PKI standard, we use something called X509 certificate to prove yourself. That's a certificate, right? But when you go there, when you use an application, how will you prove? Example, let's say when you use an iPhone, of course you have a Face ID, you have a fingerprint ID if you're using an old one. I have an iPad which still has a fingerprint ID, but you got the point, right? You have to prove yourself. You have to prove that you are that person which you're claiming to be, and that is your digital identity. And that's very important in the blockchain world, right? Because when you say you own something, you have a wallet, and in a wallet you have a very important phrase with you, which is your private key. And to access that private key, you need to have some identification, maybe your fingerprint or Face ID, something which you can prove. And also, when you talk about certificate, we have to also maintain a list of certificates which are revoked, right? Because of course, getting a certificate is important, it's easy. But how about if you lose a certificate, if you do something and if it is expire? So there has to be a list where you can say this is revoked list, and everything will be mentioned there. So once we got an asset, once we know the identity, was the next thing. Remember we talked about smart contract. Now smart contract is actually not a new term which is coined now. It's there from a long time. And maybe if you're exploring blockchain from a long time, you know the history, right? We got Bitcoin, but before Bitcoin as well, there were some thoughts of using smart contracts, smart economy or something like that. Now even before that, they tried to use cryptocurrencies, they tried to use smart contracts. And this term was coined by Nick Szabo in 1994. So how do you define a smart contract? Maybe you can say a contract. So if a particular condition met, you can say that's a contract and you can execute that now. If it is happening automatically with the help of some programs, you can say it's a smart contract, right? So in the Neo world, to achieve that, we have something called Neo contract. So what is a Neo contract? So Neo contract is a smart contract system, and it's one of the biggest feature in the developer ecosystem for the blockchain. And the most important thing which I loved about this, and we have talked about this before as well, it supports multiple programming languages. You don't have to learn a new language. In this series, we are going to start with C#, but yes, if we get enough time, we'll also explore some other languages as well. But then, it also provides you something else. In fact, we'll talk about the application ecosystem later. But when you use a programming language, when you build an application, it's very important for us to have a virtual machine. No, we don't need a JVM here, but we have something called Neo Virtual Machine where you can run your code. Next, we have to understand is the application and ecosystem. See, I always believe when you talk about blockchain field, when you talk about the blockchain world, only those blockchain will survive when you have a proper ecosystem, and Neo does provide it. And if we talk about the blockchain, of course, you have multiple nodes. Your node can be a light node. It can be a full node. Of course, this the same concept there, but then a different term we use here, light node, a fully functional node. And we can also have a wallet, which is hardware wallet. That's fine. But initially we'll work with a light node in our machine, not with the full node. In fact, the idea is to also work with the private network. Because see, when you build an application, you can deploy that on a public network. But when you build it to test it, we can use that in a private network, and that should be our next video, right? The next thing you have here is if you have worked on Ethereum or the other platform. So basically, whenever you have a blockchain, whenever you do a transaction, you can explore all the transactions, all the blocks on a website. The best thing about this is it provides you a development kit, a toolkit basically, where you get something called a blockchain explorer inbuilt. You just click on a button and you will see all the blocks coming up. And in every few seconds, you will see a new block. And we have also discussed about this one. This is the Sdk Development Kit. It's not just support one language, it supports multiple languages, and you have it there. Now, the best thing is whenever you work with a language, whenever you work with a blockchain, and irrespective of blockchain, when you work on simple application, you need IDE support as well. Because to make small projects, normal Notepad or simple editor works. But then when you want to build big projects, when you want to build a project which are bug-free, getting an IDE support will be helpful. And in Neo, you do get that. And we will be using Visual Studio Code, which does provide you with the plugins option and extensions. Now, next, most important in terms of management model. In fact, we have already talked about it. Just to reiterate, Neo has two native tokens. One is Neo and second is the gas. So if you want to do the transfers, transaction fee, that will be using gas, and your native coins are Neo coins. So in total, we have 100 million tokens available for Neo, and they were launched at the start of the blockchain itself. In the Genesis block, it is mentioned, and the gas will be generated as we go. And I guess the total limit is also, the total limit is also 100 million, and it will be done in approximately 22 years. It's a long time. And then we have also talked about this before as well, right? So Neo tokens will be used for the governance purpose as well. So that's one thing. And this is distribution not required for the upcoming video. So you can just read this and we'll go ahead. Apart from this, we have chain governance. So we'll talk about this later. Now, what is important to understand is the technology implementation. And the most important thing, in fact, when you talked about basic of blockchains, we start with this topic, which is the consensus mechanism. Do we use POW, POS here? No, we have a different one, which is DBFT, which is the Delegated Byzantine's Fault Tolerance. So to understand this, we have to understand one. Let me just show you how it works. So let's say this actually started with a problem called a Byzantine's general problem, which is, let's say we have 5 to 6 generals and they want to invade a particular city or a country. And they can win this, or they will be successful only when they all attack at the same time. And the twist is they are not located at the same place. They are in different location, and the only way they can succeed is if they attack at the same time or if they treat at the same time. So how will they do it? Maybe we can do a phone call or a WhatsApp message. No, we are talking about the back old time where the services were not available. So the only way they can do this by sending a messenger. So messenger will go around and they can decide a time and they can attack. There are two problems here. The first one is, what if the messenger is itself corrupt? Or what if the generals are corrupt? Maybe even one general out of all is corrupt, then of course they will not succeed. So what is the solution here? And the solution is DBFT. In the blockchain world as well, when you have multiple nodes, we have to come to a consensus for a particular thing, right? If one of them is corrupt, we have to kick them out. And that's where we have a delegated Byzantine fault tolerance, where you basically have a group of nodes. So they will delegate a particular node as the main person. And then, in fact, we can have multiple delegators. If a particular delegate says this is a particular block which is created, all the other delegates can verify that, right? And that's how it works. Basically, we're trying to solve a Byzantine's general problem with the help of DBFT. Okay, and it says, so the average time is 15 to 20 seconds to generate a particular block, and the transaction throughput is measured in about 1000 TPS. This is a good number, which we can see. Potential to reach 1000, 10,000. Now coming up next, which is the smart contract system, which is a Neo contract. If you remember, we have talked about the Neo contract, right? So if you want to achieve a smart contract, we have a Neo contract there, which has something called Neo VM. Now Neo VM is very important because that's where you will run your code. It's almost same as JVM and .NET runtime. So for Java, we use JVM, and for .NET application, we have .NET runtime. Okay, next important thing is the dev pack. And we have talked about this before, right? We need plugins, we need extension to work on our code. And the best thing is it supports multiple languages. So you can select a different IDE. You can support a different extension for a particular language. Okay. Now, one of the issue with most of the blockchain, which I see, is the cross-chain support. See, every blockchain have a different way of working. And if you want to transfer an asset from one blockchain to other blockchain, it will be tricky, right? And Neo says, hey, don't worry. We have something called Neo X, which helps you for the cross-chain asset exchange agreement. And it also uses something called cross-chain distributed transaction protocol to achieve that. So basically, you can exchange an asset between two different chains. Storage, also important, right? So how will you store it? Will you use a normal database? No, not exactly. We have to use a distributed storage protocol. And for that, we have something called NeoFS, and it uses distributed hash table and the file content. In fact, the thing is, if you have a huge file, it will just break those files into small parts, and that will be tagged with the help of hash for the indexes. And that's how you search a particular thing. with the help of the hash value. Now coming to the most important thing in terms of security. When I started learning blockchain for the first time, and after some time, there was some questions. Hey, blockchain is great. It provides good amount of security. But what about the quantum machines? Because ultimately blockchain is secure because of cryptography, which is PKI. And with the help of quantum system, of course, it's not that mature now, but in future, when the quantum machines or quantum computers will be that mature, will it be able to sustain that? Okay, it is an issue for some of the blockchain, not now, but in future. Neo says, why to take a risk? Let's build a system which is anti-quantum cryptography mechanism. They do that with the help of Neo QS, which is the quantum safe system. So basically, you are also safe from the QS. So that's the Neo white paper in short, where we talked about different terms. We have talked about DFT, we have talked about Neo X, which is the cross-chain, and Neo FS for the file storage, and for anti-quantum cryptography, we have Neo QS. So yeah, that's about the white paper. I hope you got some idea. So once we start with the programming, it will make much more sense. Okay, so till this point, we know what is Neo. We have seen how do we do the setup for the Neo toolkit, the blockchain toolkit, and we have seen some theory as well. Now this will be helpful when we write a smart contract. But where do we have to write a smart contract? Of course, we got the answer. We have our VS code ready with us, and you can see we have empty screen now. Now the thing is, we also need to create a network. Now, why do we need a network? We have a public network, right? So when you develop an application, when you have your DApp ready or DApp ready, you can just push it on the public network. But then when you are testing it, when you want to learn something, when you want to debug your code, it makes sense to use that in a private net. And we need to use a private net. Where you will see the private net? It's very simple. When you go to your sidebar and you click on M3, and you can see here, in the blockchains, we got two blockchains. One is a mainnet, second is your testnet. And if you expand testnet, we have some seats available. And if you expand your mainnet, we have something. Now, what I want here is I want my private network to be here so that when you develop an application, you can test it there. Now, you have a choice. When you have a network, and if you want number of nodes, you can specify how many nodes you want, one node or multiple nodes, right? So we'll do that in this video. So let's create a private network. Now, in order to do that, what we will do, let's go back to our files or Explorer here, and let's create an empty folder. So for that, I will just click on Open Folder. Okay, so let me create an empty folder here. Very simple. You can just click on New Folder, or if you have already created in the earlier videos, you can use that. Otherwise, let me create a new one. And I will say this is Neo Smart Contract. I will click on Select Folder, Open. Now, once we've got our folder, yes, we have to trust this project. We trust the author as well. We don't want the starter page. So we got our empty folder. We don't have any file as of now. You can see this is empty. Let's go to M3 again. And here, if you can see, it is detecting that we don't have any. If you just go to Quicksort, this is where you will be having your wallet. This is where you will be having your contracts. But as of now, I don't need that. So let me just push this up. Okay. Now, if you focus on your Kickstart, it has detected that we don't have a Neo Express instance. Now, this Neo Express will be helpful to create our network here. So you can simply click on this. And that's why when you have a toolkit, it is much easier to create your own blockchain. So click on this toolkit. Now, once you click on that, it will say, okay, I will create a network for you. But tell me how many nodes you want. You want a single node, 4 nodes, 7 nodes? See, if you want to test your network, and if you want to test your DApp in the production, it makes sense to have multiple nodes. But since we are into learning phase, we will select one, and that should be enough. Once you do that, it will ask you for the place. And okay, so this is a folder which we created now, which is Neo Smart Contract, and we need to provide a name to it. We can say private net. That works. We can say private net, and the type is Neo Express configuration. So we'll select that and click on create. Okay, so it is creating. It will take some time, and you can see we got a prompt here as well created. Okay, we don't need that. And as you stay on this screen, you can see it is happening. This is your block explorer. Remember, we have talked about this. This is where you will be having all your blocks. After every 15-20 seconds, it will create a new block for you. Now, the funny part is in this blockchain network, which is a private network, we don't have any nodes who are doing transaction. Ultimately, we have only one node, right? and still it is creating blocks, and unfortunately those are empty blocks. And that's why you can see here, you can see the time, you can see the transaction, you can see transaction 0, which means this block is empty. Now if you don't want to see all the blocks, you can click on this hide empty blocks and it will show only one block. Any guess which is this block? This is the first block where you have all the basic information, the Genesis block. And if you click on that, this is a block which will be there irrespective if you say hide, because this will be your first block. But yes, after every few seconds it will get a new block. As of now, just click on this. Now yes, once we write a smart contract, when we do some transaction, that's where you'll be having a block which has a transaction. Okay, now if you focus on the left hand side as well, apart from this two network, if you can see, we have mainnet and we have testnet. We have one more network now, which is your private net. Now this is the same name which we have given, and if you expand this, we have the name itself is private net because that's what we mentioned when we saved it, and the extension is Neo Express. This is your file and that's your network. So the explorer which you're using here is on this network. Cool. Now let me just go back to our file explorer. So when you click on that, you can see we have a file created. Remember when we did for the first time, we were not having any files, but now we have one file, which is your configuration. When you click on that, it will open a file. This looks more like a JSON file, and it should be a JSON file which with a Neo Express extension, and it has all the information. You can see we have a private key, we have a script hash, we have some port number, and that's your wallet. Do we have a wallet created here? Yes, you can also see we have a wallet as well. Now, we mentioned that before, right? So wallet is basically not where you have your money. Wallet is useful to save your private key. So if you expand this, this is your wallet. Right, and if you want to receive or send money, you can use this and you will be having. As of now, we don't have a balance. You can see we have 0 Neos, we have 0 gas. We need to get some Neos and gas, right? Because we want to do some transaction. And we'll see that later. How do we get this Neo and this gas? Okay, one more thing. The Neo and gas which you will receive is not something you can trade on the platform. Those not exactly our money which you receive. That's a dummy amount. We can use that for transaction to learn something and experiment. Cool. So we got our wallet ready. We need to create a smart contract. We need to use this wallet and we want money. And we'll be doing some transfer between two people in the upcoming video. So yeah, that's it from this video where we have talked about the setup of private network. And just to reiterate what we have done, the first step you have to create an empty folder. We have done that. The empty folder for us was Neo Smart Contract. Is not empty as of now because we get it one file. Next we have to do is we have to create a private network. In order to achieve that, you can just click on this option here, which is the Neo Express instance, but unfortunately you can't see that. So you can see one more option is, if you don't see that option there, you can click on these 3 dots on the blockchain. You can see it says create private blockchain. Again, same thing, you have to mention the number of nodes. You can mention the name and it will create a new private blockchain for you. Let me just try that. Just enter some name. I will say testnet private, and you can see it will create a new for you, but we don't want to, right? We want only one. So you can even stop this blockchain if you want to stop it. As of now, this is running, right? We have 2 private blockchains running. I can stop this, and the moment you say stop, it will not create any more new blocks there. And I want to delete this. Do we have an option? Okay, let me see that option later. Okay, but as of now, we want one private blockchain, and this is where it will create a wallet for you, and that's it. You got a smart contract. So that's about this stuff. Till this point, we have talked about what is Neo, we have seen the white paper of it, and we have also created a private network. So basically, whenever you want to deploy your smart contract, that's what we are going to do in this video. So basically, we'll build a smart contract. Of course, we'll not write a smart contract from scratch because we are still into the early phase, right? So it's good to start with an inbuilt example, and we'll also see how exactly a smart contract look like. We'll also deploy an application or deploy a smart contract. So that's the idea. Now in the previous video, we have done with the network setup. Basically, we have created a private network, and this is what we are going to do again, because maybe when you open your VS Code, you might have lost everything. So it's good to start from scratch. So let's say you got your VS Code from scratch. Make sure that you have this extension, which is the Neo N3 Visual Div Tracker. And once you have it, we can get started. So the first thing we do is we create a private blockchain. So just to reiterate what we're going to do in this video, the first thing we'll do is we'll create a private blockchain. We'll try to build a smart contract, and we'll also deploy it. So let's start with the private blockchain. So it's very simple actually. You can just go to N3, and then you can see we have an option of blockchains here. And as of now, we do have mainnet, we do have testnet, but we don't have a private blockchain. So what we are going to do So you can see when you go down here, which is a quick start, just click on this create a new Neo Express instance, click on that and it will ask you for the number of nodes you need. So of course for the trial basis or for learning purpose we can go with 1. Click on that, it will ask you for a name. So we'll say this is private network, or we can say private net, create, and you can see it will create a private network for you. Now where you will find it, so let me just go back here. So you can see we have an option which is private net, and this is get started. We don't need this. So once we got our private blockchain, we can see we have an option of exploring the blocks, and you can see we have multiple blocks created. As of now, we don't have any transactions in them because we are not doing anything, right? And if you don't want to see all the blocks, you can click on hide and everything works. Now what next? We got our private blockchain. We got the wallet as well, and we have not talked about the wallet yet. We'll talk about it in some time. Then we have our smart contracts. Now these smart contracts are inbuilt smart contracts which are already deployed. So our idea here is to create or to build a smart contract and deploy it so that we can call it. So basically you should be able to invoke your smart contracts. Now what is smart contract in general? Say in the blockchain, or maybe you can imagine the internet, you have so many applications, right? You have Facebook, Instagram, you have banking applications, you have e-commerce website. So what we do there is we do some operations. Example, if you want to buy something, you order a product, then you receive a product, right? You make a payment as well. This is conditions. This is what you say actions, right? Let's say the moment you receive your product, there should be a deduction of money. That's a smart contract. So something is happening because of something, right? So you met a condition and you do that. So that is what is called a smart contract because it's happening automatically. And to achieve that, you have to write a code. Now, which language you will prefer? Of course, we have talked about it. We are going to work for C#, but you can use any language you want. And we'll see that in this video, what type of language it supports and how the code looks like. Now see, whenever you do a transaction in the public blockchain specifically, and Neo is a public blockchain, every time you do a transaction, you have to pay a transaction fee. Now this transaction can be anything. Example, you say you own this particular asset and now you want to transfer this asset to someone else. That's one transaction. Maybe you want to send a currency. Maybe you want to transfer 100 Neos. In that case as well, that's a transaction. Right? So whatever you do, that is a part of a transaction. So here as well, when you do a transaction, it will charge you for a transfer fee. And we have seen that, right? If you want to hold coins, that's your Neos. But if you want to do a transaction and that fee, you can give that fee with the help of gas coins. So the question is, who will hold these coins, Neo coins and gas coins? And this is where you need people, right? Of course, you need people who will hold those coins. Now, in this case, we don't have any individuals or people in the network, but we can create those things, right? We can create accounts or we can create wallets. Now, what is a wallet? So if you want to keep money, so example, whatever application you're using, maybe if you're using Google Pay or any specific application in your country to hold currency, that's your wallet, right? Or maybe you can imagine a physical wallet where you keep your money. But in the world of blockchain, wallet is not somewhere you keep money. Wallet is something where you keep your private address. So here we use wallet to keep our private address, not money, right? And this is one of the wallet you get by default. So when you click on the Genesis wallet here, and this is what it shows. So Genesis is the default wallet which you get, and it has some Neos and some gas. It is not visible as of now, but once we do a transaction, you can see the number of Neos it holds. Now, how many Neos it holds? It holds exactly 100 million Neos. Right? But don't worry, we are into private network, and whatever Neos you get here, you can't encash it. Just dummy currency you get. So basically you get some Neos, you get some gas, but that's also in the Genesis block or Genesis wallet. What we want to create here, we want to get 2 accounts which will hold those things. So even before we write a smart contract, the first thing we need in your machine is 2 accounts. Okay, not exactly 2 accounts. You can use multiple accounts or 1 account, but just for example, we'll go for 2 accounts. Now, how do we create a wallet? It's very simple. You can just right click on your blockchain and you can see there's an option of create wallet, or you can click on these 3 dots and you can say create wallet. But this looks like a good way. So you can right click on your blockchain and say create wallet. It will ask you for a wallet name. And of course, I'm creating a wallet for myself. So I will say Naveen. I will say enter. And the next thing it will do is it will create a wallet for you. And you can see down there, we got a notification that the wallet is created. Now, one thing to remember, as I mentioned before, in the wallet, you will not be keeping your currency, right? Of course, it will show the currency, but it does not hold the currency there. It only holds the private key, and the private key is visible, it's not encrypted. So when you use private network, it will not encrypt it, and that's not a good way, right? So that's what the message you get here. So the message says the private keys for accounts in a wallet are not encrypted. Do not use these accounts on mainnet. Mainnet is a main Neo network, so don't do these things on the network. Okay, let me just close that. And if you go back to Naveen, you can see we got Naveen as an account, of course the private address. And as of now, I don't have any Neo, I don't have any gas coins as well. Okay, that's one. I want to get one more account, one more wallet. So I will right click and I will say create wallet. And this time I will say Kiran, enter. And we got one more wallet here. So in total, we got 2 wallets. Let me just see that. Yeah, we got 2 wallets. One is Naveen and second is Kiran. Done. And both are poor. We don't have any coins as of now. But then if I want to do any transaction, we need to make sure that we have coins with us, right? So how do we make sure that we have some coins? Okay, so from where you will get the coins, as I mentioned before, remember, in the Genesis wallet, you have 100 million Neos, and you can't see that either, you will see that in some time. So can we do this? Can we transfer some Neos from Genesis wallet to Naveen? It's possible. Let me show you how do we do that. In order to achieve that, you can just right click on your blockchain. There's an option of transfer asset. Now this is an important word here, which is asset. See, in the world of blockchain, anything which can be transferred is an asset. You can represent that with the help of currencies. You can represent that with the help of physical asset. Example, let's say this is a physical asset, right? And then I want to represent this in the virtual world. So what you can do is you can create a digital asset of this. So in physical world, when you transfer this asset to someone, you can transfer that on the blockchain as well. And that's how you keep the records. So here we can just transfer the assets from one person to other person. So in this case, we are transferring Neos from Genesis wallet to Naveen wallet. So you can click on transfer asset. It will mention what you want to transfer. And just now we talked about any asset, right? But by default, we get 2 assets here, which is Neo and gas, that is pre-programmed. But if you want to get your own asset, you can do that. So as of now, we are clicking on Neo because we want to transfer Neo from okay, we have to also mention the amount of Neos you want to transfer. I know what you're thinking about. You want all the money, right? No, we'll do 1,000 Neos at a time. So let's go for 1,000 Neos. And you want to transfer this from Genesis to Naveen. And you can see that's one transaction. It's completed. How do we verify that? Go back to Naveen. And if I scroll down, let's refresh. Can you see that? We got 1,000 Neos. It's that simple. How many Neos are there with Genesis? Not 0 exactly. If I refresh, you can see that we got this number, which is 100 billion minus 1,000, right? And then it also holds a gas, which is a good number. Let's not count the amount of gas it has, but this is a good number. Now the thing is, if you go back to Naveen, Naveen does not have any gas. You can see we have 0. Same goes for Kiran, here we got 0. But if you wait for enough amount of time, Naveen will get some gas. How? For free? Exactly. So the Neo blockchain, whenever you hold Neos, it basically gives you, it will generate gas for you. That's a reward you get. But then we don't want to wait, right? I also want to transfer some gas from Genesis to Naveen. So we'll do that, but we also want to transfer some asset from Genesis to Kiran. Or maybe I can transfer. I have 1,000 Neos. I want to transfer 300. We can do that. Right click, transfer asset. I want to transfer Neo. How many? 300. From Naveen to Kiran, and let's verify. So let me verify from Naveen first. Oh, now that's the thing, right? We talked about this and I forgot to mention. It says insufficient gas in address. Remember, if Naveen is doing a transaction and Naveen is transferring some asset to Kiran, it will charge you some gas, and we don't have a gas as of now. So step 1 is to transfer the gas, let's say I want to transfer 5,000 gas coins from Genesis to Naveen first. It will take 15-20 seconds to update. Let's refresh. Okay, still not there. Refresh. Okay, we got 5,000 gas, and now I can do the transaction which failed earlier. So now I want to transfer Neo, 300 Neos from Naveen to Kiran, and the transaction is submitted. It will take some time to reflect. Refresh, you can see there's a deduction of a gas from Naveen. It's around 0.00, okay, some number. Doesn't matter. It was reduction of some gas, and if I go back to Kiran and if I refresh, you can see we got 300 neos. So that's how you transfer neos, and that's how you transfer the gas as well. So further examples will not be using Kiran much. We'll only focus on Naveen. So Naveen has some neo coins and some gas, and that is enough for us. So just to reiterate what we have done, we created 2 wallets apart from the Genesis wallet. And one more thing, you can't do all those things if your blockchain is in stop phase. Example, let's say if I stop this blockchain, you can see we don't see any information. We don't even see the wallet. So how do we start our blockchain? It's very simple. Either you click on this Start Neo Express. This quick start is very, very helpful. You can click on that, or you can right click on the blockchain and say Start Blockchain. Both works. So even after you refresh or restart your blockchain, you can still see the same amount, because of course that's the wallet, right? Cool. This is what we have talked about the wallet. So that's the step 2. So the first step was to create a private blockchain. The step 2 was to create a wallet. Now let's go for step 3. Now the step 3 is, it's very simple. You need to create a smart contract. Now, as I mentioned before, we're not writing this code from scratch because we are still in the learning phase. We are learning so many things at the same time. There's one more thing before we go ahead. I forgot to mention about this block. Remember when we do transaction, every time we do a transaction, it becomes a part of a block. Now the thing is, for that particular 15-20 seconds, we were doing only one transaction. What if we do more transaction? That becomes a part here. So in each block, you can have more transactions, but since we only had one, you can see a number 1 here. And when you click on any of this transaction, it will show all the values, the Merkle root, the block hash, and you can get some more information when you click on this transaction ID. It will show from where you have done this to what person. Let's say if I click on Naveen, it will show the current wallet address, and it will show the balance as well. Yeah, this is what you get all the information. Great. Okay, so once we have done this, the next step is to create a smart contract. We'll not be doing that from scratch. So how do we create a smart contract? Now, remember the quick start, it's very, very helpful. So you can just go down. It will say, hey, you don't have a contract in your code. And nowhere you can see we got any contract, right? The code is, you have a blank code. I just created this new folder. If you have already created one, you can just stay with that. Let's go back here, and with the help of quick start, let me create a contract. It's very simple. Just click on this button. Now it will ask you for 3 options: C#, Java, or Python. That's a supported language for this particular toolkit. If you want to use some other language, there are other options as well. But as of now, these 3 languages are famous, we can use it. But what if you don't see an option here, which is create a new contract? You can actually right click on your blockchain, and there should be, okay, where is the option of creating a contract? Yeah, so you can just click on these 3 dots in the smart contract. It will ask you for the option of create contract, and you can select that. Otherwise, I will just simply click on create a new contract. Click on that. The next thing it will ask you for is a language name. So we have C#, Java, and Python option. Initially, we'll go for C#, click on that. It will ask you for a contract name. So just to keep it simple, we can go with hello Telusko as a name. You can go with anything. They also give an example, which is token escrow. We can go with that. Otherwise, let's say hello Telusko, and click on enter. The moment you do that, it will take some time and it will create a contract. Now this might create some issues for you. There might be some reasons. One is if you don't have a proper runtime. So first thing you need in your machine is a runtime, which is 5.NET SDK 5. It should also work with 6, but for some reason it was not working for me. So you can try 5 and 6. If 6 is not working, .NET SDK 5. The next thing you will need is a compiler. This code is actually getting built. And to build that, we need a C# extension. You can just go to the extension tab and you can search for C# and make sure that you get the extension from the Microsoft, and you can see we got it here. So this is the extension from Microsoft, and done, we got the extension, right? The next thing you need is the compiler, specifically for Neo blockchain. Now to do that, we need to use our terminal. So maybe I can just say new terminal. And here you need to install your C# compiler. Now, once we got the extension, the next thing we need here is a compiler. So let's enter the command to achieve that. So basically you have to say .NET tool install -g, and you have to mention the compiler name, which is Neo compiler, C#, and done. So .NET tool install -g, neo.compiler.c#. Now, If this does not work, you just have to mention the version number as well. And it was working for me, and you can see it says already installed. Otherwise, if you want to mention the version number, you can say version. And I think the current version you can check on Google as well. You can go to their official website and you can check the current version. I think the current version should be 0.0.2 or maybe 0. It should also work. Now, since I already have in my machine, I can just go with clear, and that's done. Let me just close this particular shell and let's go with the original one. So done, we got our smart contract, right? So we have to install two things. The first one is the C# extension. The second one is the compiler. And now if you go back to your file explorer, you can see there's an option of contract. So you can see a folder which is hello Telusko, in which if you expand, of course you have different JSON files and a project file. If you expand src, and if you look at this contract, the extension is CS, which is for C#. And if I click on that, this is your smart contract. Okay, now what this smart contract says, of course, we don't want to go in depth of this code as of now because we are into the learning phase. We'll write this, we'll modify the smart contract, maybe we'll write our own just to see how thing works out. But as of now, we have some metadata here. You can change your name here. You can say your name is Naveen. You can mention your author name, which is Naveen Reddy. You can mention your email ID and you can mention the description. Let's not waste our time there. And how do we create a contract? It's very simple. In C#, in Java, you use a class name. So you create a class and you mention a contract. And you don't have to build everything by yourself, right? You can use inbuilt classes or interfaces. You can see we have a smart contract here as a class. We'll inherit that. Now, if you want, every time you want to perform an operation, you do that with the help of a method, right? Or a function. So this is what we're doing here. You can see we have a change number. That's a function or a method you can call. We have deploy, get number, update contract, and you can call this methods. And that's when you say you invoke a contract. Cool. So this is your smart contract. We'll also update. Don't focus on the code as of now because the language might change in future. Maybe Java, maybe Python. As of now, we are focusing on the core idea of contract. Now, once you have this contract ready, we need to put this contract into a blockchain because this contract is not a part of a blockchain. Let's see if it is really there. Okay, it's there, but it's not deployed yet. So we'll deploy that. Don't worry. So we'll push this into the, let's verify. If I say invoke contract, okay, it's already there. Now, once you have your contract ready, it's time to deploy your contract. Now, what are the steps for that? It's very simple. First, you go to run or you go to terminal and there's an option of run build task and it's already done actually. Behind the scene, oh, it's done. We got our smart contract. It should also create object folder where you have all the object files, but that's fine. Okay. So step one, you need to build your smart contract. We have done that. And let's deploy this on the blockchain. So what is the process? It's very simple. Go to N3 and you can see it will say there's a contract in your Visual Studio Code workspace that is not currently deployed. And it will give you a prompt and so it's so helpful. See, if you don't have this toolkit, it will be always difficult to write this code from scratch and do everything from scratch. So click on deploy a contract. It will ask you for which blockchain you want to deploy this. I want to deploy that on private net. Click on that. Now it will say, okay, you're deploying your smart contract, but tell me from which account you want to do that. But why do we have to mention the account name here? Think about this. Or maybe you can use a comment section to answer. So the answer is there are two things. First, who is giving the sign to do that? Who is authorizing it? And second, who will pay the transaction fee? Right? So you can say, okay, Naveen is doing that. This is a smart contract and it will take some time to deploy and done. You can see it says deployed. Awesome. It will also be available here. And now you can also invoke it. So you can say invoke. You can say it says invoke a contract. You can mention which contract, which blockchain you want to go for, private blockchain. And in the private blockchain, we have so many methods to do to invoke. But what we have done till this point is we created the wallet. Why do we need a wallet? Because that's where you save your private key. So different people will have a different private key. And of course, one person can have multiple private keys, but that's a different story. And next, you need to build your smart contract. You have to write it, you have to build it, and you have to deploy it. Now, till this point, we have talked about what is Neo. We have created a project, a simple project, and then because of the toolkit, we got the project as well. Now, in this project, we already have a smart contract, which you can see we have not seen the code exactly. But then now we are talking about invoking it. So basically, we have done with the build, we have done with the deployment, and now we have to invoke those smart contract. So let's explore this code a bit before invoking it. So what we are doing here is, if you can see, we have a very simple smart contract here, which is a hello Telusko contract. And whenever you have a class, whenever you want to define a smart contract in C#, you create a class and then you extend, or maybe you inherit from a base class, which is smart contract here. And of course you will get all the basic feature. Now in this we have some functions, and ultimately we are dealing with a number here. And one thing to remember, whenever you work with blockchain technology, in most of the blockchain technology you have transactions and you have a permanent storage. And here as well we have something similar to it. Not exactly same, we'll discuss that later how it works, but then we have a transactions and we have a persistent store. So basically whenever you want to access the entire blockchain, we can do that with the help of contract. But then what if you have some private data? What if you want to store some data which is only related to particular contract? In that case, you can put that in a store, right? So what we are doing here is, if you can go to this function or a method called change number, we are passing a number and then we are assigning that number to our storage. That's it. A simple stuff we are doing here, right? The only thing we are checking is if the number is negative. If the number is negative, we'll throw the exception. Now this is a very simple smart contract. We're just trying to change the number. That's it. I mean, you can do whatever you want. You can add two numbers. You can just store the data somewhere, or maybe you can transfer assets. We'll see that later. But as of now, we are focusing only on this particular smart contract, which is mentioned here. And then what we want to do here is we want to invoke this particular smart contract by passing a value. Now, how do we do it? For that, let me just go back to N3 again. And you can see we have our blockchain running. If your blockchain is not running, you can just right click here on your private blockchain and you can say start blockchain. But if you can see the wallets here, that means your blockchain is running. And once you have your contract deployed, once you have everything set up, it will show you an option here, which is Invoke Contract. Just click on that. And it will ask you where you want to do that. Don't do it on mainnet because we don't have actual currency, and don't test your code on mainnet. So let's use our private network here. And these are the options you get. So most of it are inbuilt smart contract. We don't want to focus on that. We want to focus on the smart contract which we created. I mean, given by the VS Code. But then this is interesting. You get a file here, which is untitled neo-invoke.json. This is a file, interesting file. Let's explore how this file looks like. Now, where do we see this? So if you go back to your Explorer, you can see invoke files. And if you expand that, there's a file called untitled neo-invoke.json. Click on that. You can also see your JSON. Or you can see that we got interactive mode. You can actually click on switch. It will give you a JSON structure. But let's go back to let's go back here and then we'll again go back to JSON. Now, first of all, I don't like this name untitled. Let me just give a name to it. I will say first. Doesn't matter what name you give there. I will say first. And here, again, you got the option. Now, what we want to do, we want to invoke this particular method, which is change number. And how simple it can be. Just click on that. And you can see we got a contract name. This is a window you get. You got a contract name. Then it says, hey, what type of operation you want to perform? Because in one contract, you can have multiple actions. You can perform multiple operations. Okay, so I can say when you click on this, it will show you all the available methods. We want to focus on change number. And this change number will be expecting a positive integer or a positive number. So you can give any number here. Let me just give 5 if that works. Yeah, 5 should work. And we are passing a number which is 5 here. And that's it. We are calling this contract. Specifically, we are talking about this operation. We are passing a value and then we just need to click on this one, which is run this step. Okay, now it will ask you for something. It will ask you for an account. From which account you want to invoke this. Of course, remember we have to pay a gas fee. So we'll click on Naveen. Naveen will be calling it. And as of now, let's skip to the witness as global. And done. We have submitted a transaction. For some time it will show pending here on the right hand side. In some time it will be confirmed. And now it's confirmed. Let's check what has happened. If you can see this properly, we are invoking this smart contract. And then notification says everything is good. There's a change in the state, and that's done. Everything is working. So basically we submitted a value and it got assigned to a store. So in the storage, the number is stored, right? How do we see this in step by step? So what if you want to see this in step by step? We have another option. But before going to that option, I want to show you how it looks like in a JSON format. So we have invoked And now if I click on switch, this is a JSON contract which is creates. So we got a contract, we got the operation, and we got a value, right? In fact, what's the fun part? If I go back there and if I click on the transaction, and if I click on so you can see we also see a value here. So basically it is sending the values as well because that is stored in the JSON, right? But what if you want to say this in maybe a step-by-step format? You also have a debug option here. So you can click on debug step and you can mention who will be debugging it and it will start the process. But before we debug, normally what we do in programming is, first of all, what is debugging? Debugging will help you to remove bugs, and that's very important in the world of blockchain. So you have to debug the application, and if you want to start the debugging, you have to set the breakpoint from where you want to start the debugging process. So this is the point where I want to start debugging, right? From this particular curly bracket. So it's very simple. Just click on this bubble here, and now this is where you can start with debugging. But how will you do it? Go back to your JSON file. Can you see that option there? Debug this step. In fact, I will change this number so that we'll know something is changing here. So click on debug this step, and again the same thing. It will ask you for the person. This time we'll go with Kiran just for change. Okay, you can see that we got a checkpoint here, and now let's start with these steps. Okay, so we got step over. We are going on to the next field. Now it is not executing this part because the number is positive, so it is skipping that part. And now we are going for the next step, which is the contract. So you can run this step over and you can see the steps as well, and it will show you in the debug console as well when you do that. So one thing to remember, when you see this variable, you can see we have the variables available in that particular contract. You can also keep a watch on the variable, and you can do this all with the help of this debugging step. So I think we are done with this. Yeah, that's how you invoke a particular smart contract. And so that's our first journey, right? The part one of the basics. So we have talked about neo basics. We have talked about creating a smart contract. We have talked about invoking it, and done. That's our steps. So basically till this point, we have talked about neo blockchain. We have talked about the white paper, and now it's time to create our first smart contract. In fact, we have done that before. We have used the existing smart contract which your neo provides, but now we want to write our first contract from scratch. Of course, we'll not be doing anything difficult. We'll do easy part. In fact, we'll start with hello world contract. We'll try to put some data. We'll try to retrieve some data and see how this works, right? Now for that, what you need to have in your system, or maybe if you have following the entire playlist, the first thing you need is a private blockchain. You can see we have a private blockchain here. If you don't have a private blockchain with you, you can just click on these three dots, and it will show you option of creating a private blockchain. So make sure you do that. Of course, you can give any name, doesn't matter. The next thing you need is a wallet. In fact, we'll need two wallets just for the testing purpose. And you can see I have created two wallets here, Naveen and Kiran. If you don't know how to get a wallet, it's very simple. Right click and say create wallet. It will ask you for the name. Just mention the name and you will be having a wallet here. And as you can see, we have wallet. But then Kiran already have 1,000 gas coins. You will not be having it if you're doing it for the first time. So in that case, if you want these coins, you can ask the Genesis block, which already have a lot of coins with the Genesis block. You can just ask for the coins. How do we do that? So Genesis can transfer assets to you. Now assets can be coin, assets can be physical assets. I mean, you can convert a physical asset into a digital asset. So you can right click and you can say transfer asset. You can specify what you want to transfer. Let's say I want to transfer gas. I want to transfer another 400 gas coins from Genesis to Kiran, and you can do that. It's so simple, right? After some time, when you refresh this example, let's wait for some time, and when it says it's completed, transfer transaction submitted, okay, it will take around 15-20 seconds, and when you say refresh, you got your gas coins here. And that's it. Once you have this, we can write our first smart contract. Now how do we do that? So in order to write your first smart contract, you can just click on these three dots and you can say create a contract. Now you have to select a language. It can be a C# language, it can be Java, it can be Python. Now since C# will continue with that. So click on C# here. And you can mention a name here. So I will say first contract. Of course, you can give anything, but I will say first. I will say enter. And that's it. This is your first contract. It is taking some time to build, and I think it's done. Okay, but then we don't want to use this existing contract which is mentioned here, right? What we can do is we can build our own. So instead of using this one, I can just say select all and delete. We'll write this code by ourselves. Let's have this using statement before. Now, what is using? See, what happens is it doesn't matter which language you work with. It can be Java, it can be C#, it can be Python, C. Whenever we use some functions, now these functions or methods can be inbuilt, or these functions can be user-defined functions. Now, whenever you have inbuilt functions, which our programming language itself gives, that's very simple stuff. But if you are using some external libraries, you have to mention from which library you are using these methods. In this case, we are using C#, so we are using using, pun intended. But for Java, we use import. For C, we use include, right? And then we have to mention the library which you are working with. We are working with Neo here, and that is there. Okay, now once you specify the import packages, the next thing you need is, it's time to write a code, right? Now what exactly we are trying to do here? So we'll create a smart contract where you can put data, where you can fetch data. See, every time you put data, it's a transaction, right? It will do some processing, and it will do the transaction for you. So you have to pay a gas fee. We also need a signature, and we'll see how that signature works behind the scene. Or not behind the scene, but in the code. So how do we write a C# code? So in the C#, the first thing you need to mention is the namespace where you are going to use this. And I will mention this namespace as first, not test, first. And there's one more thing, when you explore these files, when you create a contract, it will give you some files. As an example, in the SRC, we got first contract, right? But then most of the development nowadays happens with the help of test-driven approach, where you also have a test packages. So in the test package, if you explore this first contract test, it will have some methods which will test your methods. But just to keep it simple, for this example, which is not a good practice again, but just to keep it simple, since we are into learning phase, I will right click this and I will say delete. Okay, don't do that, but in the real world, but since we are learning, we can do that. And the next thing is, since I'm deleting a folder itself, there is a directory or DIRs. So there is this file, project file, from which you have to mention that you don't have this. In fact, it says include, but then we don't have it, we'll delete that, so that it will not give you any error. Again, only for learning purpose, don't do it in production. Now, once we got our namespace, the next thing you need to do is you have to create a class. Now, that's how you do it in Java or C#, or maybe if you're using Python with classes or Python with OOPS. We use class. So we have to say public class. Now, why public is because it can be accessed from outside as well. And then you have to mention the name of a contract, which is first contract in this case. And that's it. It looks simple, right? But the problem is, whenever you say, hey, you're creating a contract, it has some special meaning to it. It has some special features. And to get those features, you don't have to code it by yourself. You can use the existing class. And the class is smart contract. You can just use that class. It will have all the features of a smart contract in your class. And don't worry, this is not an empty class. This is an inbuilt Neo class or pre-built Neo class. And here you can find, there's no suggestion, but that's fine. It's a part of Neo package. Simple stuff, right? Now what we want here is we want to do a very simple code where we can just add data, or we can add some data in the contract or in the blockchain. Now specifically when you talk about the contract, it uses, now the difference between blockchain and a persistent store is in a blockchain, when you have your data, it can be accessed from any contract. So let's say in the network, you have multiple projects, and multiple projects have multiple contracts. Anyone can access that data. But what if you want to have a storage where only a particular contract can access, and that is done with the help of a persistent store. And we'll see how do we use a persistent store. So there's a special class called storage, and we can use it to store data. So basically, we can create variables as well. If you're coming from different languages like Java, C#, C, we use variables, right? In here, we call them as properties because it holds data. Now, these properties can be a property which can be changed, or we can have a constant values. When you want to use constant value, we can use const keyword, and that works. Otherwise, you can use normal properties. Now, one of the question is how exactly this data is getting stored in that store which I was talking about. So basically, it uses something called key and a value pair. So whenever you want to store the data, that's a value. It needs to have a key to access that. Of course, right? If you save something in a database or in a blockchain, how will you fetch it? You have to specify a key to it. Example, so I can say Navin Reddy. So what is Navin Reddy? It's a name, right? So name is a key here, and Navin Reddy is a value. So that's how you store data. And every data will have a type to it. Example, in programming language like we have other languages where you mention the value and a type to it. Example, 5 is an integer, Naveen is a string, A is a character. In the same way here as well, we have some properties or data types we can use. Okay, so we'll define those variables later, but as of now, I want to save some data, right? So what we can do is we can create a method. So that's how we do it. We create methods in C#. So we'll say public static because I don't want to get object to call this. So I will say public static void because I don't want a return type. And I will say I will create a method called add data, not date, add data. That's it. Very simple stuff, right? You create a method and it should work. Now the only thing is you might want to pass a value. So let's say here I can just assign a simple value to it. But what if I want to pass a value while calling this contract? So in this case, you can pass the object. It can be of any type. And I can say object, I want to send the data. So whatever data I send here will be assigned to the store which you're talking about. But again, I'm just keeping that optional. You can just skip that part. You can just save any data you want. So where exactly you want to store this data? So I can say storage, there is an inbuilt class called storage dot put. Now put is a method which you are calling. Now this put says, okay, my job is I will assign the value, but you have to provide me 3 things. The first thing you have to mention is the current context. Now why do we need a context? See, whenever you work with a particular smart contract, this data is only available for that particular smart contract. But what if a smart contract is calling another smart contract, which is possible, and that smart contract can call another smart contract. We can have a chain of smart contracts calling each other. And whenever you have multiple smart contracts calling each other, maybe sometime you want to pass the data as well. And as I mentioned before, when you talk about persistent store, it is only available for that particular smart contract. So if a smart contracts want to share the data with other smart contract, they can send this context as well. We can call them as a store context. So here, if you want to mention that it's a current context, so you can say storage dot current context. Okay, that's the first parameter. The next 2 parameters are very simple. The second parameter is actually the key which you want to specify. So I can say name, that's the key, and the value which I want to send here is Naveen. That's it. So I have a key Naveen name and the data is Naveen. It's that simple. So that's my saving. That's what I'm doing to store data. How about fetching this data? It's very simple. You say public static. Since we are fetching data, so we can say string, and I can say get data. And in this bracket, you don't have to mention anything in bracket because you're fetching data this time. And open close. Now how do we fetch data? Now first of all, we are fetching data, so we can say return because we are returning value. Now from where do you want to return this value? From storage, right? From the store. So I will say storage dot. Any guess what the method name can be? That's right, it is get. In bracket, again, you have to specify 2 things now. Any guess what those 2 things are? The first is from where you want to fetch it, the context, right? So the context is storage dot current context. And the next thing you have to mention is, see, in your store, you'll be having multiple values. And to fetch one value, you have to specify a key to it. And the key I want to fetch here is name. And if you specify some other key, it will not work. Now this looks very simple, right? And it is actually very simple. Let's run this and let's see if this works. So what are the steps you have to follow to run this code? So the first thing you will do is you will just click on this terminal and you can say run build task. And you can mention your code we are working with first. That's the name of your contract. Click on first and build done. Is it done? Okay, so it is building. You can see that in the bottom. And done. Build is done. There's no problem. And I love when we don't have any errors. But yeah, let's go to N3. And now it's time to deploy this project there. So right click here and say, where do we have deploy? So you can see we have a deploy contract to new express. Do that. Now, whenever you deploy stuff, it will ask you for your account from where you want to deploy this. And I will say I want to deploy it from Naveen. And what's the contract name? It is your first contract.nef. Click on that. And then it will take some time for the deployment. And of course, it's also a transaction. So there will be a deduction of a transaction fee. And it will take some time for the completion. And it looks like it is deployed, completely done. Yeah. So once it is deployed, you can just right click and now it's time to invoke the contract. The moment you do that, you can see we have so many options here. And then we have seen this before as well, right? But then the focus is on our contract which we have built, which is the first contract. I can say get, but don't you think we'll not be having any data with name? So first we'll add it. So click on add. So that's the contract name. The operation we are trying to achieve is add data. Click on that. And here you have to pass the data. Of course, whatever you pass will not make any sense because we're not using it. But just for fun, let me just pass the data. And once you have passed it, click on run this step. Of course, you can click on debug as well. But let me click on run this step. Now, when you say run, again, it's a transaction, right? Who will pay it? Who will sign it? So we'll say, okay, Navin will do it. Now, this is important. Now, this is something which was introduced in Neo 3, but specifically 3.1. Because see, there are some issues when you talk about contract. Remember when I mentioned about a contract can call a contract and that contract can call another contract? Now, when you have this chain of contract, it is possible that the contract which you have built is solid. I mean, there's no bugs to it, or it's not malicious. But what if you are, by mistake, you're calling a contract which is malicious? Or maybe it was good initially, but now it is malicious. And what happens is, whenever you call a contract, you sign it, right? You have to provide a sign, and that's what we have done before. The problem is you are signing only for that particular contract, not the subsequent contracts. Now, what will be the issue? The issue would be you just want to transfer 10 neos to your friend, and you're doing that with a contract which you built. But what if that contract is calling a malicious contract which says, hey, I got a signature, and using that signature, I can do whatever I want. So they can get a hold on your wallet. In fact, it's not specific to Neo. With every blockchain, we have something common. If you own an asset and if you are signing it, that means only you can do it. How do we control this? Because for a transaction, we sign it, right? We don't mention which token belongs to which person, right? And that's why we use public key infrastructure where we have a private key concept. Here as well, it goes a step ahead by saying, even if you call multiple contracts and one of the contract is malicious, and that malicious contract is trying to work with your asset, you can deny it. And that's why we got a witness scope. So witness scope says we have 3 options. In fact, we should get more options here. When you say none, it means it cannot call any of it, any of the contract. And it's not that useful. It has a very different purpose. Let's focus on this too. When you say global, it means you are signing for all the smart contract. So even if you have a malicious smart contract in your code, they can access whatever they want, right? They can transfer tokens. It's not safe. So basically, don't use global. It's not safe. Always use called by entry because you're mentioning only this particular contract can use this signature. So select this one, and it will take some time for the transaction to get complete. And you can see there's a pending state here. Just wait to get it completed. And done. You can see we got confirmed. Click on this one. I hope there was not any error. Everything looks cool. So this is the sender, Naveen. This is the data which we are passing, but ultimately this data will not be used. You know why? Is because we are getting this data, but we are not using it. Of course, you can replace this Naveen with data and that should work. But as of now, we are not doing it. And everything looks good. It is not returning anything. That's why it says result is null. But the fun thing will be when you try to fetch this data, and let's see what happens when you fetch this data. So I can click on this get data. So I will not be using add data now. I will be saying get data. And I don't have anything here. Delete this. So basically get data is not having any parameter. And now with this get data, say click on this, run this step. Again, same thing. You can mention which account. I can say, let's try with Naveen itself. Naveen called by entry. And again, you will see a transaction here in pending state. So again, you can wait for 15-20 seconds and it will be up and you can see it is confirmed. Click on this one and you can see the same stuff, but important is the result. Can you see that result is Naveen? Because that's what we have stored, right? So we were trying to fetch name. It should be same somewhere here. We're trying to fetch get data. Oh, the method name is get data, right? Not name. So when you say get data, it will give you data and the data, I mean, in the code itself, we are mentioning what you want. In fact, you can be very specific. When you call get data, you can actually pass parameter. That will be the assignment, okay? Pass the parameter and get the data from here by mentioning the key. That's one. But then this contract is still not secure. And second, maybe if you want to delete this, destroy the contract, we should be able to do that. So in the next video, we'll try to add some restrictions and we'll also try to destroy the smart contract. So yeah, that's it from this video. I hope you enjoyed where we have written our first smart contract. Just to reiterate, it's a very simple smart contract. You just have to extend a smart contract. We are adding data with the help of put, and we are fetching data. So this is a storage where you're trying to put data. We can also use storage map where we use as key value pair of multiple values, and even that works. So in the previous video, we created a smart contract, a very simple one where we are able to add data and we are able to get data. But we want to add some features to it. The first feature I want is to destroy the smart contract. So can we do that? Let's try. So what I will do here is, in fact, let's not do that in the same code because again, we will deploy that and it will give you some error. So what we will do is we'll create a different smart contract. We'll say second contract. I know that sounds weird, but let's do that. So I will just right click here, or maybe where to right click here. So I will say create contract, and again C#, the contract name is second. Okay, this is our contract, but then we don't want this code exactly. So I will just go for the first contract, copy and paste it here. The changes we want to make here is this is the namespace of second. This is the contract, which is second. Now, whenever you do this type of changes, one thing to remember is you have to also delete. So can you see that we got two contracts here? And in the second one, again, we have a test folder. Right click, delete. Don't do that in the production environment. And the next thing you need to do is in this particular file, delete this line as well, which is looking for the test folder. And that's it. Close this one. We got our contract ready. Let's see if the contract is ready. Where is the contract? It's here. Okay, now what are the things we need to do here? We need to add a method which is destroy. So I will say public static void destroy. Now, how do we destroy a contract? It's very simple. There is a class called contract management, and it has a method called destroy. That's it. It's that simple, right? Now, there's one problem here. We can destroy the contract, of course, but then who will destroy it? Who has the power to destroy the contract? So how do we check the owner of the contract? That's important, right? Only owner can delete that. So first, the condition is we need to find the owner of a contract, and we have to check who is trying to delete this contract, and then you should be able to do that. So we can apply a if condition to check for the owner. But the question is, how will you check for the owner? To do that, it's very simple. First, I will define who is the owner of this contract. So we can do it here. So I can create a variable or a property, you can say, and I want this property to be only read-only because no one should be able to change it. So I will say read-only property, and the type of this property, I want it to be uint 16 or 64 should be good. Maybe it will be a longer value, right? So in Neo, the private key or the address is of hash 160. So to accommodate that, we can use this type of data type, which is uint 160, and you can mention it's the owner is equal to. Now, how do you assign the owner? To assign that, actually, we can say default here because we can pass the value with the help of the marker. So we can do that here. So in the square bracket, you can say initial value, and in the bracket, you can mention the address, and then you can also mention the type of the address. So the address is hash 160. So the type of the parameter is hash 160. That's done. But then we have not assigned the type yet. But then we have not assigned the address yet. So we'll do that in some time. So let's assign the address. Now, where you will get the address? So who is the owner? So I can say Naveen is the owner. So I can just click on this M3 and click on Naveen here. And this is the address of Naveen. Copy this and go back to the smart contract and paste. That's my address. Now, if you use any other address and if you try to run this code, it will give you error. So please use your own address, and otherwise it will not work. So what we can do here is in this if condition, we can check if it is the owner. And to do that, we can also create one more method here. So I can say public static boolean, and this will return if that's the owner or not. So I can say is owner. And we can create a Lambda function. This is what you call it in Java. I'm not sure what do you call it in C#, but we can use a shortcut. You can say is owner, and it should only check if that's the owner or not. And to do that, we have some inbuilt functions as well to check if the calling person or the signature is of the owner or not. And we can do that with the help of runtime.checkWitness. In the bracket, you can mention owner. Okay. And that's the problem, when you switch between multiple languages, you get confused with the standards which a programming language follows. Okay, so basically for destroying, we are first checking if it is the owner. So here we can say if it is not the owner, then we can throw an exception. So I can say throw new exception, and you can say not allowed. Of course, right, only owner can destroy the smart contract. In fact, we can also verify whoever is calling it is actually the actual owner. So I can say public static bool, and we can define a method called verify to do that. And this will only check if that's the owner. We could have simply called owner is owner, and that should work, right? Let's say this is owner. Okay, so we have added some methods, and this should work now. I don't see any problem in this code. So we are trying to destroy, we are checking for who is the owner, and maybe we can also try it with Kiran calling the smart contract. Let's try. So first of all, it's time to build this. So I will say run build task. I want to build the second smart contract. Okay, it says there's a problem. Okay, namespace. Oh, I forgot the most important part. This all should be a part of a class. How can I forget that? My bad. Okay, now let's try once again. Let's run and second build. Okay, this time build. Okay, there's another error. I thought it would be completed. It says contract parameter type does not exist in the current context. So let me add this smart contract separately. It was not there, and let me just run this code. Okay, so the problem was we have to add extra library here to make it work. I guess we did that only with these namespace, right? Okay, my bad. Cool, so once we have this up and running, build is done. It's time to deploy it. It's very simple. Just right click here and say deploy the contract. Who will be deploying it? Who is the owner? It's Naveen. Second contract, and it's taking some time to deploy. I hope it will not be giving any error. Okay, it seems it is deployed. Now it's time to invoke it. So click on Invoke Contract. Which one we want to invoke? We want to invoke the second one. So we'll not be adding and get data this time. We'll simply say, let's verify who is the owner. So we'll click on verify. We are calling this verify and run this step. So who is running this? I will say Naveen, call by entry. So it should say true. There's a test here because Naveen is the owner. Click on this, and can you see that we got true? That means it is true. So we actually verifying who is the owner. And now let me run this with the help of a different user, Kiran, call by entry, because Kiran has a different address, right? So when I say, okay, it's saying pending, we'll wait for some time. And done. When you click on this one, you can see we got false. So basically that's how you can verify the owner. We can perform other options as well. You can just write out in your machine. You can again add data, you can get data, you can say is owner. And that's how you try out different smart contract. So just to reiterate what we have done till now. So basically if you want to check for the owner, we can create any function, that doesn't matter, but we can check the witness, right, which is the owner in this case. And then we can set the address as well here. And if it changes the address for a different user, that user becomes the owner. Okay, that's it. This is how you create a smart contract and you add extra features. Now till this point, we have talked about Neo basics. We have written some code as well to get our first smart contract, but that was simple, right? And then we have this question, how can we use this in real world? Now, first of all, we are trying to find all the solutions, or in fact, we are trying to find problems which are already solved in Web 2.0, and then we have to move them to Web 3.0 because that's the future, right? So how do you build an application on 3.0? Now the use case we are going to use here is domain registration, which is quite famous use case, right? So let's say we'll build an application where you can register a domain, and it will be done with the help of a blockchain. Specifically, we're talking about Neo blockchain here. And then we will be able to look up, which is search for a particular domain. Maybe you want to know who owns this particular domain. Maybe you want to transfer your domain to someone else. Maybe you want to sell it. Example, the moment you have a famous domain name, someone can buy it, right? So you can sell it for some currency, or maybe you can delete it. So this is what we're going to do here. Just to keep it simple, we are not going to do any checks. Example, let's say you want to delete a domain. Now we'll not be checking who is the owner, only owner can delete it, but that's the ideal solution, right? But just to keep it simple, we'll not do that. We'll just say delete. okay? But what if you want to check? That's your assignment, okay? We'll see that, what I'm talking about. So let's get started with the code. Now, what are the things we have? We already got a private blockchain, but as you can see, the blockchain is not running. If your blockchain is running, it will show the wallets as well. And we already have our wallets, but then I have done the reset for the blockchain, and we lost all the data, all the blocks, and all the wallets. So what I will do is I will just start the blockchain. I guess it will have my wallet, but without any currency. So if I click on any wallet, which is Naveen, you can see we don't have any Neos, we don't have any gas coins. So we'll do that first. We'll get some Neos and we'll get some gas. In fact, we only need gas coins, right? So let's use that. Okay, so I will transfer some assets. I want to transfer gas, let's say 1,000 gas coins from Genesis to Naveen. And the same thing can be done for Kiran as well. I want to transfer some gas coin, again 1,000 gas coins from Genesis to Kiran, and that's done. We got our 2 wallet with some gas coin, and if you can refresh, you can see we got 1,000 gas coins, and that's enough. Now, once we have that, let's create a smart contract, because the moment you want to write a code, you will use a smart contract. So what I will do here is, as you can see, I don't have any contract as of now, but if I click on N3, and if I click on these 3 dots, I can create a contract. Now, which language? Of course, C# we are going for. The website, the project name, the contract name, we can have it domain for domain registration. And that's our contract. In fact, I already have written some code for this. I will just replace that here just to keep it simple. And now this is a simple domain contract and nothing to do with the domain name. So as you can see, it's change number, and we'll keep this action number change. We should be saying on change, right? We can do that. But we'll not be using this. We can simply removing this part. We don't need this. And we don't need this methods. We want to change this, right, for the domain registration. Okay, simple code. This is what we are keeping. Others, we are removing it. So we got domain contract, Naveen Reddy, and domain registration. Anything else we want to change? Nothing. And let's add our methods. Now, what exact methods I'm looking for? First one, I should be able to register the domain. I should be able to look up the domain. I should be able to transfer domain. I should be able to delete the domain. So let's start with the method which is register, because that's what we do, right? So let's do for the registration. And for that, let's write a method. So the method name can be public static void, because we are doing registration. We are not expecting anything in return. So we'll say public static void, and we'll say method name is register. Okay, now in registration, what are the things you have to pass? Of course, a user will enter a domain name, will ask for that. So here in the registered brackets, I can say a user will enter the domain, and we just have to take the domain and save it in the blockchain or in the store basically. So we can say, how do we store? It's very simple. We have already done that. So we can use a class called storage.put, and in bracket, you can mention the domain name. So I want to put the domain, right? But if you remember, we have to pass 3 parameters here. The first one is the context, the current context. We have not mentioned that. And second is the key. So domain will be the key. And we have to mention one more thing, which is the value, right? Value will be the user. So if I'm registering a domain, which user is owning this domain? So that's what we want. So first thing we have to mention is the context, right? So context is storage dot current context. That's done. The next thing we have to mention is domain, and we have to mention the value as well, which is the user. So example, Naveen owns that domain. How do I know? So whoever is registering, he becomes the owner, or he or she becomes the owner, right? How do I know who is calling this function or who is calling this method? So in that case, we can use the transaction object. So I can say var tx equal to, because that's a transaction. Okay, so we're getting a variable transaction, and how will I get the current transaction? So you have to use this inbuilt runtime dot script container. So you can say script container, it will give you the object of transaction. So you just have to pass the transaction here. So the moment you say script container, it will give you the object of transaction. You just have to typecast it with the proper object or proper type, and then you will get the transaction object. And using that tx, you can get the sender of this. So you can say sender. Cool, right? By doing this, you are able to store the owner of that domain in that storage. That's it. But then we also want to look up, right? So we have to write a method for lookup as well. Now, how will you do that? It's quite simple. So you can say public static. Okay, lookup will return something, right? So in this case, I want to return the value which is of type uint 160, because that's how the value will be stored. And the method name we can have as lookup. And now, how do we look up? So let's say when I say lookup, what I want to know is if I pass a domain name, I want to know who is the owner of it. So I can say string domain. Okay, but how will you find this now? So in this case, what you will do is you need to see the data is getting stored here, right, in the storage. You just have to use this storage. So I can say return, I want to return the value, but what I want to return is I want to fetch data from the storage. So I will say storage dot. Which method you can use to get the value is get, right? Okay, I forgot to put here, which is capital P, not small p. And then using this get, you can pass from where you want to fetch this. So I want to fetch this from the current context. And we have talked about it, right? Different smart contract will have a different context. So I want to fetch from the current context. And what I want to fetch is, I have to specify the key. Key in this case is domain. In fact, you can do in reverse as well. Maybe while registering, you can mention the sender as the key and a domain as a value. Now, the only problem is one sender can have multiple domains. And that's what we are doing in this way. Because one domain. So we have from sender to domain, we have one-to-many relationship because one sender can have multiple domains. But one domain can belong to only one sender. And that's why we are going in this way, where domain is a key and a sender is a value. Okay, cool. So that's how you look up, right? So you search and you return the value. It's that simple. I guess the only problem you might be facing is when you return, it might not give the same type. I want this type of data. So you can just typecast it, just to be on the safer side. So that's how we do it. We got register, we got lookup. Now what else we need here? Maybe the next thing you need is transfer. How do you transfer the domain? So in this case, I will say public static void. I want to transfer, right? I don't want any return type, so I can say transfer. And in this, what you have to mention? First of all, you have to mention the domain itself, what domain you want to transfer. So I can say string domain. The next thing you want to mention is to whom you want to transfer this. So I can say uint 160, that's my to. And then from, you don't have to mention from, right? Because if you mention the domain, we will know who that owner is. So from is not required. And then we can say, okay, first of all, we need to get that from as well. Not from the parenthesis, but from the domain name. So I can say owner is equal to, okay, which method? Maybe I can use lookup to call that. Anyway, we have that method created, right? So in the lookup, I can pass the domain, which will give me the owner as well. Simple stuff, right? And using this, I can just save the data. Now, the only thing is when you say you are storing data, you're actually updating it. So the earlier owner, let's say if I'm transferring that domain from Kiran to Naveen, the earlier owner was Kiran and now the new owner will be Naveen. So when you say update, it's very simple. You have to use the same thing. Storage.put will do both the thing. That's why it is put, not push. I hope you know the difference between put and push. If not, just go to YouTube and search for put versus push in HTTP. So we'll say storage.current context, comma. Okay, then I have to mention the key, which is the domain, and the value to whom I'm transferring to, that to. In fact, actually, we don't need this owner because anyway, we are replacing it. Now, why this will be useful? Now, I have a question for everyone. Just put that in the comment section. When I say transfer, it will transfer the domain from the owner to the address we mentioned here. But the real question is, who can do this? Anyone can transfer or only owner can transfer? If you write this type of method, you are in deep trouble because anyone can call this function and anyone can call it, anyone can transfer. We want to check first who is the owner. If the sender of this transaction and the owner of this domain is same, then only you have to do this. Okay, that will be assignment, and if I will try to make a separate video on this. How do we do it? Okay, that's done. We are done with the transfer as well. The next thing you can do here is I can say public. Okay, what other thing we need? We need delete, right? So we'll say public void delete, static void delete. And in this, I can do the same thing. Again, the same thing, right? Only the owner can delete, it should be able to delete that. But I just want to keep it simple. So I will say storage dot delete because that's the method we have. So we have method like get, put, and delete for deleting the data. From where you want to delete this, again, this thing will remain common, which is the current context. And then you have to mention the key which you want to delete, which is domain in this case. And that's it. I think we are done with the code here. We got all the things which we needed. We got a smart contract, we got register, we got lookup, we got transfer, we got delete. I hope this will work. How do I check this if this is working? So it's quite simple. Just go to terminal and say run build task. Which task you want to run? I want to run the domain here. It's taking some time to deploy. Oh, first of all, we are building it, right? Building done. Oh, there is an error. Oh, the problem is, as I mentioned before, every project will have a test folder. So the first thing you do is you delete this test folder. Don't do that in production environment. Since we are into learning phase, we are not using test cases. But test cases are very, very important. So again, terminal, run build task. I want to run this domain. I hope there will not be any error now. Okay, there is no error as you can see. Now, once you find there is no error, you can deploy this. You can just go to N3, right-click on your project or right-click on your blockchain and say deploy the contract. Now, who will be deploying this contract? I can say Naveen or Kiran, that's our choice. Let's go with Naveen. And the domain contract, this is the contract we want to deploy to the blockchain. Okay, it will take some time for deployment. Great, deployment done. And now it's time to invoke the contract. So remember the step, write a code, build the task, deploy the contract, invoke the contract. Now, when you say invoke, you will find your contract here. You can see that we got domain contract. We have register, lookup, transfer, delete. I want to register a domain name. So I want to register a domain name. Domain name is telusko.com and run. But then we have not mentioned the owner, right? So whoever is the account, so you can select the account. I can say Naveen. And of course, call by entry because I don't want the subsequent smart contract to get the signature. Okay, it will take some time. I hope it will work. Oh, great, it is working. You can see there is no exception. So it is working. So we are able to call register, and this is a domain name which we have registered. Who is the owner? It's Naveen because by Naveen we are calling this. Things are looking good. Everything looks good. Let me just close this. How do I verify? Let's do the lookup. Now, since we have two owners, who owns this particular domain? Let's run this. And anyone can check. Kiran can check, Naveen can check. Let me try with Kiran. And let's say Kiran is searching who is the owner of this domain. And done. Let's open this. And you can see who is calling this. Kiran is calling this. And response. Result says who is the owner? It's Naveen. Can you see that? Now let's say Kiran says, hey, I want to own this domain. So let's say Kiran gives a call to Naveen by saying, hey, I want to own your domain. Let's say Naveen says, hey, I will charge you around $1 million to own my domain. And we did that transaction. And now I want to transfer this domain, which is telusko.com, to, I have to mention the address. So address is Kiran. So you can say @Kiran. It will pick up the wallet. You don't have to actually mention the exact address. Just say @Kiran and that's done. And now run this step. Now, this is what you have to check. Okay. So if you have multiple wallets, anyone can do to transfer because we are not checking. You should check. And let's try to do that in the next video. But here we are just focusing on Naveen is trying to transfer. So it should be done now. It will take some time. So you can see it says confirm. If I click on that, sender, who is invoking this contract is Naveen, and transfer done to Kiran. You can see that. Let's verify. How do I verify? Of course, we can do the lookup, right? So I can say lookup. We don't want the second parameter. So we're looking for this domain now. Let's see who owns this domain. And anyone can do a lookup. Let's say Naveen is doing a lookup here and done. If I open this, you can see Naveen is invoking it. And let's see who is the owner. The owner is Kiran. This is what we wanted, right? And we got it. So close this. So checked for register, lookup, transfer. You can look for delete. So that's your assignment. Write this code and try delete and let me know if it is working for you. But as I mentioned before, this is not a production ready code, not exactly anything close to it, because anyone can do the transfer, anyone can do the registration, and we can do multiple registration, right? Because we are not checking if the domain is already registered. So to this point, we have seen how do we do the domain registration with the help of blockchain. And then we were able to do the registration, lookup, transfer, and delete. But that is still not complete, right? Because anyone can do the transfer, anyone can delete it. We don't want that. Transfer should be done only by the owner of the domain. Same goes for delete. Delete should be done only by the owner of the domain. Same goes for registration. Registration is anyone can do it, but then it should not be the double registration of the same domain, right? We have to check that as well. And then there are some pre-checks as well. Normally what you do is when you do any validation, we check for the characters. Of course, domain name will not be having any numbers. And so those things. Now, we already have a good code available. So what I will do is I will replace this code with the code available, and then we'll try to explain the steps there. So before that, let me create a new contract. I will say contract and I will say create contract. This time I will say this is the registration because this is the code given in the official website of Neo. So we'll use the same code. Let's replace this code by the code which is available on Neo website. Okay, so done the changes. You can see we got this registration contract and we have some extra things here. Now, first of all, let's verify the things which we already had, right? Oh, before that, we need to do one more thing, right? Now, since we changed the existing registration domain, it's time to delete that folder, which is test. I will say delete. And then we have to also delete a line from there. It's done here. Okay, done. Now, let me explain what is there here. First of all, we got let's do the lookup. Okay, they have one more method here. So first of all, we got get owner. It's not required. We can put that in lookup as well, but then let's have an extra method. Now, what we are doing when you say lookup. So first of all, in lookup, we are doing validation. So whatever domain name you're passing will be validated first. Now, what we are doing in validation, basic validation stuff, right, which you do in normal projects for name, for email IDs. So we are checking if the domain name has all the lower characters, right? And that's the only thing we are checking. Maybe dot will also not support it. You can add that validation there. You can just change it as per your need. And of course, the domain name should have at least one character, right? It should not be empty. Now, once you do the validation, you will get the owner. In the get owner, what you're doing is you're fetching the owner. We have done that before. And then if the owner, I mean, when you fetch the owner, it should have some value. If it doesn't have any value, it will be 0. Don't worry, you will get this code in the GitHub links. I will push this in on GitHub and so that you will find the code so that you can use it. Okay, next I want is registration. In registration as well, we'll validate first and next we'll check if the domain is already registered. And we have done that before, right? Now, what extra you are doing here? Only we have not done the check before, right? So how do we check? So first of all, we get the owner and we'll check for the particular domain if it is non-zero. If the domain is already present, if this returns a non-zero value, then domain is already there. That means we'll print already registered. In terms of transfer, this is something different now. In terms of transfer, we are doing multiple checks. This was the important check for me, which is only the owner should be able to do the transfer. So that means the invoker of that method, if it is same as the owner, then it works. Otherwise, if it is not the owner, then you will say not authorized, because check witness will give you the value which is the current signer who has signed this invocation. But then we can do some extra checks as well, right? What if the domain is not there? If the domain is 0, not registered, because how can you transfer something which is not registered? And then what if this receiver is invalid? In that case, we'll say invalid transfer, right? Now we can have one more check for delete. In case of delete as well, we can check that same thing. Domain should be there before deleting, and there should be the sender of the transaction should be same as the owner. Otherwise, it will say not authorized. So that's a check you can do. But again, the concept remains same. The basic things we have done already. So that's your domain registration on Neo blockchain. So yeah, that's it from this video. I hope you enjoyed. Let me know in the comment section and do subscribe for further videos. Bye-bye.